All right, so I just wanted to show you something called the rational root theorem. So this is not something you might not need to know this. I just don't know in your future class. But basically, let's say you didn't have access to a graphing calculator, or let's say they didn't give you one of your solutions to start. Well, how could you even get it started? I mean, one way is you could just plug and chug, and maybe you get really lucky. Maybe you find something that does make this equal to zero. Like you just plug in random numbers and just hope. Because remember, if it's a zero, basically, if you plug it in, you're going to get zero. But that's pretty unlikely, especially depending on if you're dealing with pretty complicated stuff. So this rational root theorem, basically, let me just make sure I have this straight. All right, so sorry about that. I just wanted to double check so I didn't mess up. But you're going to look at your leading coefficient and your constant term. And your constant term is going to be your P, and your leading coefficient is going to be your Q. And you're going to list your factors of these two things, and you're going to list them as the P on top over your Q. So like factors, like what I mean by that is numbers that divide into that. So like your constant is 6 or -6, really doesn't matter the sign. So what are numbers that divide into 6? Well, 1, and you always put a plus or minus because technically then -1 would divide into. Plus or minus 2 would go into 6, plus or minus 3, plus or minus 6, and then that would be it. Our leading coefficient, like our number in the very front, well, that's really 1x cubed, so that's just 1. So I mean, the only thing that divides into 1 is either 1 or -1. So from this fraction we just created, we're going to make a list of numbers that could be solutions. So basically anything you can make from this fraction are potential zeros. So we might have, like, for example, plus or minus 1. Like if you did like this 1 over that, like if you looked at this and this, you could also have 2 over 1. You could also have 3 over 1. Then you could also have 6. Like, I mean, if you just pulled anything out of this fraction we just created, these are all things that could be solutions. These are not solutions themselves. We got to test these. So you could plug these into that original equation. So like in your calculator, it's helpful if you type it in with parentheses so you can kind of edit what you have. But like, for example, if you started with 1, maybe, I mean, if you plug this in though, I mean, or if you did this mentally, that would be 1 plus 6 minus 13 minus 6. You're going to see that doesn't work out. I believe you get -7 if I did that right in my head really quick. So you want to start testing other things. Maybe try -1. You'll see that also doesn't work. But if you, I think +2 works. Let's try +2 if I remember doing this one earlier. Okay, so I mean, if you did +2 from this list, you would get 8 plus 4 times 6, that would be 24, minus 26, minus 6. That would work because this 8 plus 24 is 32. 26 minus 6 is minus 32. So you get that this is equal to 0. So basically what we found is that 2 is one of our solutions, but you might get really unlucky. One, your list of choices can be a lot bigger, and a lot of times you'll have like fractions to test. But like sometimes you might have to plug in a few numbers before you get it. So that's why I showed you how to use your graphing calculator. It's table. Or a lot of times teachers will give you a solution, or maybe you'll know one of your answers and you're trying to find the other ones, depending on what you're actually using this for. But now we would do synthetic division, just like we would in like all our other problems. So like, I mean, you would have the 1, the 6, the -13, the -6. And you would just like bring this down. That was a -6, just so it's clear. So this would be x squared plus 8x plus 3. That doesn't factor out nicely, so you would have to do quadratic formula to solve. But just for illustration, that's how you would do this. Um, without a calculator, like I said, I'm not sure next year if your teacher will make you do the rational root theorem or if they'll just use the calculator method. I feel like most people let you use a graphing calculator to kind of get these kind of problems started. But just in case, maybe if you are, maybe, I mean, you probably won't remember this anyways, but maybe you'll kind of remember doing it. And usually it's easy, like anytime you're relearning something, it's always easier the second time around. So, but if you're interested in kind of learning more about this, this is the rational root theorem. But this is how you would kind of come up with a solution if you're not given one, or if you weren't able to kind of use the graphing feature of your calculator. I guess like one situation where this would be super necessary is, let's say all of your answers were decimals or fractions. If you use that table method I showed you, that's not going to show up in your table. Like that's like one thing, like where how I'm teaching it, there is one flaw with the way I'm teaching you it, but honestly, 99% of the problems you're going to be given will probably have one nice solution in it. So, but here, I just made a second video of this because I messed it up in the first one I was doing.